Hi, I'm Rich with insideHPC. We're here at ISC 2017, and I'm here with Gilad Shainer. Welcome to Frankfurt, sir.
Thank you very much, Rich. It's good to see you again.
It is, and I'm glad we could talk today because I understand you've got some very exciting new technology to share.
Yeah, we announced a new technology called SHIELD that enables much better resiliency to systems, to HPC systems. And just before describing SHIELD, let's take a high-level view on the system and what we're trying to solve. So we live in a world of data, and people need to analyze growing amount of data and need to analyze it much faster. So that's why you need to do multiple changes within the architecture of the data center. The first main change is to move the data center architecture from a CPU-centric one to a data-centric one. Right? In the past, people had to move data all the way to the CPU before you can analyze the data. And in the world of data, when you need to do things in real time, that doesn't enable you to do that. And that's why we saw the trends of moving computational capabilities outside of the CPU to other places. And basically, you want to be able to analyze the data wherever the data is. For the network, it means that you want to analyze data in the network. And let's drive the in-network computing architecture or technology, and that's what Mellanox brought as the SHARP technology, doing tag matching and hardware and so forth, which enable us to actually do data analytics or working on the data as a data move. So this is one big trend, and this is one big technology transition to move to the data center architecture and in-network computing. On the other side, you need to increase the resiliency of the fabric or the network or the system, right? Faults in the network might happen. Of course, it's not common, because if it was common, that was a different problem to solve. But when it happens, then the way that people deal with it today is actually by creating alerts that goes to a software management that can go in and try to overcome the failures, do rerouting of the data or other things like that. People also created the abilities to do checkpoint and restart, which is kind of a band-aid on those items, right? Which means that you need to save data every once in a while, so if something happened, you can get back to the last good known state of the application.
And that takes time, especially with a big system with a huge network of clustered nodes.
Right. Yeah. So if you look on a typical network, if something happened and you need the software management to come and try to solve it, that takes order of seconds. It can take 5 seconds for a 1,000-node system. It can take 30 seconds to a 10,000-node system, which is a long time. So what we did is we brought a new technology called SHIELD. And SHIELD actually enables the hardware, the network hardware, to overcome failure in the network by itself. It's bringing self-healing capabilities into the network. So the network can identify if there are faults. And if there are faults, the network will overcome the faults by doing a smart rerouting within the fabric. And in multiple cases, there is actually communications that happen between the elements, between the network elements, to find the most optimal change within the fabric to overcome those failures. So now instead of waiting 5 seconds, for example, for software management to come and overcome a fault, now it takes you a millisecond. So we're talking about 5,000x increase in the fabric or the network resiliency and bringing self-healing capabilities into the network. And that's another major technology that's going to help us to drive toward exascale.
Okay.